Hi everyone. In this lesson, we are going to introduce matched or paired samples. You'll learn how to recognize paired data, calculate the differences, check the conditions for a paired t-test, and write the hypotheses. Then, in the next video, we'll use the TI-84 to perform a complete paired t-test. Let's begin. The hypothesis testing procedure is exactly the same as Chapter 9. If you have already learned hypothesis testing from Chapter 9, the good news is that the overall process hasn't changed. The only difference is that our data are now paired. Instead of comparing two separate samples, we'll calculate the difference for each pair and perform a t-test on those differences. So what are matched or paired samples? Matched data occurred when each observation in one sample is naturally paired with one observation in the other sample. Usually, this means we are measuring the same person, object, or location twice. Let's look at example 1. The first situation is the blood pressure before and after medication. This is paired because we are measuring the same patient twice. The second situation is the heights of boys and girls. This is not paired because the observations come from different individuals. Next, gas mileage using two types of gasoline on the same car. This is paired because we are testing the same car under two different conditions. Finally, average exam scores from two different classrooms. This is not paired because the students in one classroom are different from the students in the other classroom. Whenever you are deciding if data are paired, ask yourself one question. Can I naturally match each observation in one sample with exactly one observation in the other sample? If the answer is yes, then the data are paired. Once we have identified paired data, the next step is to calculate the difference for each pair. For the difference, we'll just take one x value minus the other x value. But in this course, I am going to use a slightly different definition because I think it's easier to understand. So we'll define the difference as the after value minus the before value. Why do I prefer this? Because if something improves after the treatment, tutoring, or program, the difference will be positive. I think that's more intuitive. You could also define the difference as before minus after. That is mathematically correct too. The important thing is that once you choose an order, you must use that same order throughout the entire problem. Your hypotheses and calculator setup must match the way you defined the differences. After calculating all the differences, we'll treat those differences as one sample. The population parameter is called mu sub d. It represents the population mean difference. Now, let's continue on example 2. We have a table listing the before and after values, and we want to find the difference. Since we are using after minus before, we'll subtract the before value from the after value. For the first pair, I take 78 minus 82, which equals -4. For the second pair, I take 73 minus 75, which equals -2. For the third pair, I take 91 minus 90, which equals 1. These three differences become our sample. Notice that negative differences are not bad. They simply means the second measurement is smaller than the first. Positive differences means the second measurement is larger than the first. Before performing any hypothesis test, we need to check the conditions. There are 4 conditions for a pair t-test. First, the data should come from a simple random sample. Second, the observations must be matched pairs. Third, the differences should be approximately normally distributed, or the sample size should be at least 30. Notice that we are checking the differences, not the original data. Finally, there should be no extreme outliers in the differences. In many textbook problems, you simply be told that the normality condition has already been checked. Now, let's write the hypotheses. For every pair t-test, the null hypothesis is the same. It states that there is no average difference. So HO will be mu sub d equals 0. The alternative hypothesis depends on the claim. If the claim says different, we use mu sub d is not equal to 0. If the claim says greater, we use mu sub d is greater than 0. If the claim says less than, we use mu sub d is less than 0. Now, let's complete example 3. The problem says, a researcher believes students score higher after tutoring. Identifying the null and alternative hypotheses. We're looking at the scores before and after tutoring. This is a paired t-test. For every paired t-test, the null hypothesis will be mu of d equals 0. For the alternative hypothesis, we need to check the difference. Since we are defining the difference as after minus before, if tutoring helps, the after scores should be larger than the before scores. That means the difference should be positive. So the alternative hypothesis would be mu sub d is greater than 0. And this is a right tail test because the alternative hypothesis contains the greater than symbol. Now, let me point out something important. Some textbooks or instructors define the difference as before minus after. If they do that, the difference would be negative when tutoring improves score. So the alternative hypothesis would become mu sub d is less than 0. Notice that both methods are correct. The only thing that changes is the direction of the alternative hypothesis. As long as your hypothesis match the way you define the differences, you reach the same statistical conclusion. For this course, we'll always use after minus before because I think it's easier to interpret. If something improves, the difference is positive.